In this video for lesson 7.5, we're going to be talking about proportions in triangles, specifically two theorems, the first one being called the side splitter theorem, and the second one being called the triangle mid-segment theorem. Okay, so let's start with our first theorem, which is the side splitter theorem, which says if a line is parallel to one side of the triangle. So we can see inside this triangle, here's the segment MN, and it is running parallel to side AC. We know parallel means the lines never cross each other, they just run side by side. Okay, so they usually use little arrows on the lines to show you that those are parallel. Okay, so if a line is parallel to one side of a triangle, then it intersects or touches the sides, okay, intersects the other two sides and divides those sides proportionally. Okay, so point M, okay, wherever that point is, that cuts this side into two little baby parts. Let's call this A and B. Okay, line point N will cut side BC and split that side into two little parts. Let's call this C and D. And this theorem says that those sides are proportional. They make a proportion. So the two split pieces from the left side, A over B, are proportional to your two little baby pieces from the other side, C over D. That's what this is saying up here. It's just using the names of the segments. Okay, so the line in the middle is splitting the sides into proportional parts, which we can then use cross multiplying to solve. So let's do these examples here. Okay, example 1, I can see that line AT is running parallel to OW, so we can use our side splitter theorem. So this point A is splitting the left side into two parts, okay? And point T is splitting the right side into two parts. So our theorem says that this makes a proportion. So the two pieces from the left side, 16 and 8, are proportional to the two pieces from the right side. Now make sure you just go in the same order. I did my first fraction, I went top over bottom, 16 over 8. So I have to make sure I go in the same order, top over bottom, 12 over x. And then we use our cross multiplying. 16 times x is 16x. We set that equal to our other cross product, 8 times 12, which is 96. So to solve for x here, it's just a quick little one-step equation. We just divide out the 16, and we should be getting 6. So on this question, x equals 6. Done. Okay, so side splitter theorem. It splits the sides into proportional parts. So let's do a second one here. Again, I'm going to set up my proportion. So I know that this segment right here is splitting my sides into two parts. So the left side, x over 12, and the right side, x plus 1 over 15. Again, making sure I go in the same order that I did the two fractions. Okay, so same steps as always. We cross multiply. X times 15 is 15x. When I do my other cross product, just make sure it's 12 times everything, not just the x, it's 12 times the whole piece, x plus 1. So when we distribute that 12, we end up with 12x plus 12. Bring down your equal sign and your 15x. And then the rest is just our algebra. So I'm going to get my x's on the same side. I'm going to subtract this 12x over. So that gives me 3x. Bring down my equal sign and the 12 that's left over on the right side. And then when we divide this out, it should work out to be that x equals 4. Done. Okay, so again, side splitter theorem. You're using the same pieces from the one side, set it proportional to the two pieces on the other side. So you go ahead and try this third example. Okay, start by setting up a proportion using the side splitter theorem. You know, these are your parallel sides. So U is splitting the left side into two parts. C is splitting the right side into two parts. So go ahead and set up your proportion. Okay, if you did it right, it should look something like this. X over 6, the left side numbers, over x minus 2 over 4, the right side numbers. So now, finish this question. Go ahead and solve for x. Okay, when you cross multiply, you should get something that looks like this. Okay, 4 times x. Okay, and then 6 times this whole thing, x minus 2. So when you distribute, you get 6x minus 12. And if you solved it correctly, final answer is x equals 6. Okay. On the second page, we just have one last theorem to talk about, and it's called our triangle mid-segment theorem. Now, for a second here, think about the word mid-segment. Okay. The mid-segment in this picture is this line here, GH. So if this is the mid-segment, that means that it is in the middle, okay, of our triangle. Middle. Okay. So our theorem says if a segment joins the midpoints of two sides of the triangle. Okay, so what that means is G is the midpoint of side DE. So it cuts DE in half into two congruent parts. Baby equals baby. Okay, it's also true for the other side. H is the midpoint of EF, so it cuts EF into two congruent baby pieces. Okay, baby equals baby. Now, a common error that people will make here is they'll want to set the two like top pieces equal to each other. But those are not congruent. They're different. Okay, it's the two sides have equal babies and the other two sides are equal babies. But it's never the babies from different sides. It's always coming from the same side of the triangle. Okay. So our theorem here says that if we have a mid-segment, okay, then the segment is parallel to the third side. So here's our parallel sides again. Okay, similar to the first theorem we did. But if this is a mid-segment, then that mid-segment is half as long as the third side. Okay, so for example, let me erase this, make it a little less messy. Okay, if our third side here, DF, is say 10, then the mid-segment that's exactly in the middle is half as long. So that would be 5. Okay, so that's where this formula comes from. The mid-segment is half the length of the third side. Okay, now similarly, we can kind of reverse this theorem a little bit. If I know, say, the mid-segment is 4, then I know that this third side, okay, its parallel side, has to be twice as big. So that's where this second formula comes from. So if the mid-segment is 4, I know the third side is 8. It's twice as big. Okay, so you can kind of use either equation. It kind of depends which one you prefer. And I'll kind of show you examples where we can use that. Okay, so let's just start with this example number 1. It says given BC is the mid-segment of our triangle. So BC is the mid-segment. So what that means, by definition, is that B is the midpoint of side AD. So it cuts AD into two congruent parts. Okay, similarly, C then is the midpoint of side AE. So it cuts AE into two congruent parts. And again, remember, the two tops are not congruent. It's side equal to side equal to side. Okay. And then we also know that our mid-segment is half as big as the third side. So it's going to be half as big as the side it's parallel to, DE. So that's what it means. Anytime they say that something is a mid-segment, all of this is true. Okay, so let's fill in our missing pieces here. We want to find the length of AC. That's this length right here. Well, I know it has to be congruent to CE. So if CE is 18, so is AC. Okay. The second one's asking for the length of AD. Now that's the entire side here, AD. Okay, so we're going to use the mid-segment piece here to help us. If AB is 11, so is BD. They're the same. Baby equals baby. So if both babies are 11, the whole thing is 22. Okay, last piece here, they're asking for BC, the mid-segment. Well, our property says that the mid-segment is half its parallel side. So we just have to take half of 38. So let's see, what's 38 divided by 2? We get 19. So this is 19. So that's how we apply the triangle mid-segment theorem. So let's look at example 2. It's going to be very quick. Okay, if we want to solve for x, well, x is that parallel side. Here's our mid-segment right here. I'll maybe make it yellow so it stands out. So if the mid-segment is 7, I know that our parallel side has to be twice as big. So we just double 7. So that makes x then would be 14, twice as big. Okay, so let's do one that's a little harder maybe. Let's look at this example. Okay, now there again, I showed you up here that there's 2 ways we can set up the equation. We can either say that the mid-segment is half of the third side, or we can say if we double the mid-segment, it's equal to the third side, the parallel side. So I personally like this option better because then I don't ever have to worry about working with a fraction. So the problem to set it up, we double the mid-segment, set it equal to its parallel side. Okay, so here's our sides here. Here's the mid-segment. Here's the side it's parallel to. So our theorem says that if I double the mid-segment, I can set that equal to the third side. So that's what I'm going to do here. I'm going to take 2 times the mid-segment, 2x minus 5, set that equal to its parallel or third side of the triangle. So 2x plus 4. Then I never have to worry about a fraction or anything like that. Okay, so I'm going to distribute this. Give me 4x minus 10. Bring down my equal sign and everything on the right. And then the rest is just our algebra. Okay, so I'm going to get my x's on the left side. I'm going to subtract the 2x over. So that gives me 2x. I'm going to add the 10 to the right side. So 4 plus 10 is 14. So 2x equal to 14. So that makes x equal to 7. Okay, so again, you can use the mid-segment theorem. You double the mid-segment. That has to be equal to the side it's parallel to. So I'm going to have you try these last 2 examples on your own. See if you can figure it out. So number 1 is just like the first example I did, where you're just filling in the blanks. So go ahead and try this one. Okay, if you did it right, then you can use that yn, okay, is congruent or equal to en. So if en is 8, so is yn. Okay, to find es, okay, well, es is our third side, which is parallel to the mid-segment. So in order to find that length, we just double the mid-segment. So 2 times 13 gives us the answer of 26. And last but not least, ys, well, that would be this whole segment. Okay. So all we know, if this is the mid-segment, then these 2 babies are congruent. So if yo is 5, so is os. So if both baby pieces are 5, that makes the whole segment 10. Okay. Number 2 is a solving question. So it's very similar to number 3 that I did above, where you'd have to set up your equation. Okay. Using that, 2 times the mid-segment is equal to the third side. So something like this. So go ahead and finish this question and solve for x. Okay, if you distributed, you got something like this. Now your work might be a little backwards for me, but in the end, we should all get the same answer, which is that x equals 12. Okay, so this video did cover a lot. It covered our two other theorems from lesson 7.5, which is that mid-segment, that segment that's exactly in the middle of the triangle, and then the side splitter theorem, which again does not have midpoints. It's not in the middle. It just divides the sides into two proportional parts.